All right, I'm going to discuss how sound is handled internally to the player. The player uses VLC in order to play media files, uses VLC libraries. Internally, this creates a series of numbers which represent the height or depth of the audio wave. So if the audio wave happens to be a sine, as you see in this example from Wikipedia, it samples the sine frequently, and we get a set of numbers. And those numbers approximate the curve of the wave. Now, a sine wave is simple. The actual audio wave is very complicated. But nonetheless, the idea is still the same. Now, when the data gets sampled, when the audio gets sampled very quickly. 44,100 times a second is fairly typical. And so you get a lot of numbers. So 1 second worth of audio data is quite a bit. The audio data can be integers, it can be floating point. There's several different ways of representing it. But anyway, that's what's in the system, is all of this audio data. And this is, as I said, a Wikipedia page. Now, it's pulse audio that we're using. And here is Pavu Control is its name. It's a standard Linux program that you can, if it's not already installed, you can easily install it. And you see I'm running OBS, which is recording this session. And it's picking up the microphone that I'm speaking on. And there's nothing else playing. If I start up my player over here, you'll see now there's two more items in the Pulse audio channel. There's a monitor of the microphone. That's the microphone meter on my system. And there's something else that's not moving here. That's the monitor of the internal channel. That's the monitor of anything that's playing on the system, which when I play will, of course, be VLC. Now I'm going to go over to here to settings and turn off the video, because I really don't want that popping up. It bothers VLC. So when I hit play here, it's going to start playing this media file. You're not going to see the video because I just turned it off. And that will cause, well, you'll see what happens. All right, you can see the meters are now jumping. You can see the spectrum analysis is showing. This is a spectrum analysis. Red means low frequency. Purplish means high frequency. Size of the circle means the volume. And in most music, the bass is the loudest. So that's why you see the red on the outside. Down here, you see the left and right channel. You see the difference between the two, and you still see the microphone. Now back over here, you'll see not only my microphone jumping, but you'll also see the other sync here, which is a source, by the way, is a microphone in Pulse terminology. It's something from the outside. Sync is internal. So the internal is the music playing. And this is me this is me monitoring the data. This is me monitoring the microphone. This is me monitoring the music that's being played internally, which is actually trying to be sent to output devices, to the headphones. And that's the display of what it's actually trying to send out to the headphones, but the volume's off so you're not hearing it. Input devices, there's the microphone, there's configuration. I've got multiple pieces of hardware here. There's a webcam, which I'm not using. It has a microphone, and there's the built-in audio, which I am using, and I'm not using the HDMI, which is connected to a TV. The playback over here, there's the VLC, because VLC is working here. It's not actually the VLC player standalone, it's VLC libraries that are being invoked, but they show up here. Yeah, it's libVLC. They show up here looking like VLC. But, you know, that's what they are. Now it's switching to another. Well, I guess I only played one. It was all right. Now it's another one started up. And, okay, so you can see all this stuff going on in here. Isn't that exciting? So that's all the internal channels, and there's a lot of them. If you type in the command PACMD pulse audio, everything PA means pulse audio, list sources, it will show you the sources that it's seeing internally, and there's a lot here, and you don't really want to play around with it too much because it's confusing. And but anyway, this is the internal sources, which I have to probe through to figure out who the default internal one is. But anyway, I do. So when the music is playing, there's a pulse audio sync. That sync is being used to drive the meters. It's also being used to create the frequency analysis spectrum. There's also a source, which is the microphone. And that's being used to drive the microphone display. It's also being used by OBS. OBS is picking up the mic. It's calling it mic here. It's just called source here. But yeah, that's what's going on inside it. So PAVU control, PAVU, pulse audio volume control, is a good one to have. There's a bunch of, as you gathered, there's a bunch of commands that you can use. PACMD is one of the ones that can be used to control pulse. If you're careful, it'll reset when you reboot. Say apropos pulse, it'll show you commands that use the word pulse, and there's quite a few of them, as you can see. Anyway, PAVU control being one of them there. PAVU meter is the one most people have. It's a horizontal bar meter that comes pretty much standard with pulse audio. It's quite old. Actually has some errors in it. Anyway, that's pulse audio. That's going on inside when these things are playing. So we see, how do I get the meters to bounce? How do I get the spectrum analysis? How do I get the data? How do I process it? In Pulse, it's a callback system. What you do is you contact Pulse and you figure out which sources and which syncs you want to talk to, and you establish connection with Pulse. In this case, there's two connections, one with the microphone, the other with the default internal source. And then you give Pulse the name of a function to call. When Pulse calls the function, it'll send you data, recently collected audio data of some length, a vector. It'll be a vector of some number of data points it's collected. And when it sends them and how long is, it's something Pulse pretty much decides. You give it some hints, but it doesn't necessarily follow the hints. When it calls your function, your function is running as a function of Pulse. It's running in the Pulse thread, so you really have no control over it. But it's your function, and data that your function collects or grabs from Pulse can be used by you. All right, so here it is in the background. This is the function, the callback function for the sync. All right, so whenever the music is playing, Pulse will call this function periodically, and it will pass down a pointer to the stream. It says it passes down a length. I don't really use this length. I get another one. And there's a third parameter. I don't know what it is. I'm not using it, obviously. I've forgotten what it is. All right. I set up a pointer, P, okay, to void. And then I call a Pulse function, PA stream peak. Pulse audio stream peak. I've got it up here. I've got it up here. There it is. There's a whole bunch of, there's a million Pulse audio functions. Here's peak. And what it does is it reads the next fragment from the buffer for the stream. It reads a vector, in other words. And it gives, you pass it the stream, it returns you a pointer to the data, and it tells you how many bytes it sent. All right, that's just one of many, many, many functions. You can go quite crazy playing with Pulse audio functions. Anyway, so it comes, I go down there and I ask for data. Pulse called me. Now this function was called by Pulse. This function, still running in the Pulse thread, called Pulse back again and says, all right, send the data, I'm ready. So Pulse sends back a pointer, P, that's why I'm passing the address of P, and it sends back a length, which is why I'm passing the address of L. If it comes back negative, something went wrong, and we're out of here. All right, so I got this P, and I transfer a copy of it to another pointer called audio data, casting it to be float in the meantime. The way I've set it up, and there's different ways of setting it up, I've told Pulse that I want to get floating point values. Just plain float, 4-byte float. You can ask for several different formats, but I'm asking for 32-bit float. So that's what's coming back. That's why it's cast to float. All right, so I've got another copy of the pointer. It's the same pointer, obviously. Samples. L is the length of the vector in bytes. each of the items in there is going to be a float. So divide the size of a float into the number of items and you get the number of samples, the total number of data points that I'm getting. Now, what I'm getting in the VLC stream is normally stereo. So two samples, two items are a single data point, left and right channel. Although it could be mono, in which case one item is a sample, full sample. Someplace else in the program, I find out how many sync channels there are, and I transfer that locally into n-chan. So n-chan is the number of channels. I have a tiny floating point array called levels, which is initialized to 0 initially. If the number of samples is less than 2, in other words, I drop it. There's no sense going on. Everything is mostly coming back. It's coming back stereo. It could be monaural, but it isn't. In my case, it's not monaural. Anyway, if the sample size exceeds a certain value, which happens to be 400, then I copy the first 400 of the vector. There may be more, but the first 400 are copied into an array called exchange buff. Exchange buff will be used by the Fourier transform. All right, and you have to have a certain amount, at least a certain amount of data to do the Fourier. It's got to be 400 data points, or 200 stereo data points. All right, so that's copied in there, and it will be used later on when the Fourier kicks in. But remember, I'm running as a function of pulse right here. All right, and I set a flag saying, hey, I've got data. That'll be turned off once the Fourier analysis uses it. All right, well, the number of samples is greater than the number of channels. In other words, samples will be decremented, and when I get down to less than the total number of channels, it means I don't have any samples left. I set an integer c, and what this is going to do is it's going to alternate 0, 1, 0, 1, 0, 1. It looks more complicated than that, but that's all it's doing. It's alternating between the stereo channels. I bring in to v, the floating point variable I declared v, I get the absolute value, floating point absolute value of the data point. So if it's negative or positive, it all comes back positive. It's the absolute value. All right. If v is greater than levels sub c, well, c is either going to be 0 or 1, then I make levels. I'm looking for the highest point in this sample. I'm looking for the maximum data value in this sample. So 0 is, let's see, 0 is the left channel, 1 is the right channel. So I'm finding out which is the largest left channel, which is the largest right channel, and so on. I increment the pointer by the number of channels, which is 2 normally, and that increments it technically by 8 internally. So the pointer is incremented to move to the next sample. We start at the beginning and we start jumping through them. Remember, you're doing arithmetic on a pointer here, so 2 means actually to increment by 2 times the length of the item. In this case, the item is 4, so it's incrementing by 8. And I decrement the channels by the decrement the samples by the number of channels. So it goes down by 2 each time. And I keep doing this until I've gone through all of the samples and I've found the largest value of the left channel and the right channel. Then I come down here and I ask if a global variable, not declared here, declared elsewhere, is less than levels sub 0. If it is, I make it levels sub 0. In other words, left chan, if the biggest value I've found is greater than left chan becomes that value. If not, left chan stays what it was. Ditto for right chan. Okay, and you can see left channel and right channel are associated with level 0, level 1, and I return. What's going on here? What am I doing with this? Well, we've got more than one dancer on this stage. One is Pulse, which is asynchronously calling this callback routine. I don't know when it's going to call. I don't know how many times it's going to call. It's what Pulse is doing its thing. It's calling this function. Meanwhile, in my program, I have a timer which kicks in by default 10 times a second. You can change it, but by default it's 10 times a second. That timer is what drives the meters. That timer is what calls the Fourier transform if needed. If you're displaying the frequency analysis, it calls it. All right, that timer, when it comes in, wants to know what's the biggest value for the left channel and the right channel we've seen since the last time we were here. And that is what it uses to draw the meters. Then it sets left channel and right channel to 0 and goes ahead and does whatever it wants to do. In the meantime, the callback is kicking in, and it will start over again looking for the biggest left chan, right chan. So a tenth of a second later, when I come back, I've got the most. I've got for the previous tenth of a second the highest value, and that will drive the meters. All right. So in the interval, my interval, which is once 10 times a second, I want to know the biggest value that's occurred in the previous tenth, and that's what's happening. But I don't know how many times Pulse has called. You could put diagnostic software and find out how much it's calling. It calls quite a bit because it's a lot of data, 44,000 data points per second, 2 values per data point, left and right. So it's a lot of stuff's going through here. All right, so that's what's going on with regard to the with the stream. And the microphone is very similar. Microphones are called sources. All right, let's see if I can find the timer in here. Pulse and nit timer. There's 2 timer here. Here's the main timer. It's roughly by default it's once every 100 milliseconds, 10 times a second, and it's pretty simple. But it kicks in, and this threads business is to keep the threads from trampling one another. It seems to help. I don't know. But when we get here, right chan and left chan are the maximum values that have occurred in the previous tenth of a second. All right. I take the log base 10 of both of them plus 1. That's in case they happen to be 0, and ticking log of 0 is frowned upon. So I get the log base 10, and I multiply it by a fudge factor. The fudge factor is tuned to make the meters come out correctly, and so that there's enough amplification. So I forget what the fudge factor is, but anyway, there is a value there that basically tunes the value, so the meters don't all go halfway up. It's a multiplier, so they go all the way to the top, type thing. So anyway, it's trial and error to get the factor. All right, so why do I do that? To make it correspond to VU meters, which are in decibels, which is a logarithmic scale. If I didn't do this and I just used the values, it would be a linear scale. So as you know when you're doing it, let me bring up OBS here. You can see OBS is, it goes from, these are dBs, and when you get up to the top, the very high end here, a small value really bounces. Or actually a loud value, it takes it. But if I just go silent, you see this way down here. These are very low levels. So the low levels are amplified and the higher levels are compressed. Is basically what it works down to. As you can see here, the numbers get closer and closer together, and they're further and further apart up here. Anyway, that's a logarithmic scale, and that's what people prefer to see. So I'm doing a log, and let's see. All right, the value I just got in, I shift into an array. The arrays are R-chan and L-chan. You can guess what they mean, left channel and right chan. First of all, I shift the array 1 slot higher. So I make space at the bottom. So these 2 for loops are actually just shifting everything up 1. There are 100 element arrays. And then at the bottom level, I put R-chan and L-chan. These numbers are used when you create a display of the audio levels. When you create a graphical display of the audio levels, it gives you the most recent 100 values. When you go across here, let's see if I can bring it up without causing problems. All right, let me go to settings, and let me go to turn off tower effects. That's frequency spectrum now. And if I turn off spectrum, you'll see, and I have to go down, bar density has to go to 1, and you'll see that's the audio playing in the background. It's not very loud. But these are the most, as they progress along, you're seeing the most recent 100. This is the most recent one on the left, and you see every tenth of a second it increments. Those are actually tenths of a second. You don't need to go much faster. That's usually pretty good. It looks smooth. It may or may not look smooth depending on whatever the sampling rate on OBS is, but that's what's going on. So that's where there's your 100 items. And let me go over here and stop that so it's not making noise in the background. All right, so that's what these are. Those are that range, the most recent 100, and you put the most recent value into the beginning. All right, there was some fiddling around with averaging the most recent couple in order to smooth it out. I'm not doing that at the moment. You see it's commented out. You might want to play with it. All right, so it's set up the data, at least for the amplitude settings, these settings of the VU meters and so forth. How do we get them to do? Well, we queue up draw events. Draw 1, draw 2, draw 4. There is a draw 3, but it's actually a clock and it's not presently being used. So these are queued up, and the system will now, in its own thread, queue up a drawing event. And we've got here the 3 drawing spaces. We got this one here. I don't remember their exact numbers. This one here is a drawing space. This is a drawing space. And if I open up graph, this is a drawing space here. Okay, those are the 3 drawing spaces that it's talking about. Those 3 drawing spaces. Where are those drawing spaces? I'm glad you asked. If I go down here and I go to player.glade and I say display, sometimes you don't have to say display. It depends on how it's set up. All right. They're hard to. There's draw 1. Okay, this guy's draw 1. Let's see if I can find draw 2. Draw 2. That's draw 2. There's the meters. Now, draw 4 is the one that I usually hide. You can search for it up here. Draw 4. Where's draw 4? Right there. There's draw 4. Okay. So what happens at this point here, it queues up drawing activities. Now, each of the functions, on draw 1, on draw 2, on draw 4, underscore each of them in this after the word on draw 1, 2, 3, 1, 2, 4. There's underscore draw. It's a function that gets called by the system. It actually draws in those areas the data in question. And it looks to see what data you want. Are you drawing meters? Are you drawing graphical representation of the audio levels? Or do you want a Fourier transform? So it does whatever, they do whatever they need to do in order to draw the information. If the, like draw 4, the large one is normally on the screen, if it's not normally on the screen, it'll just return immediately. Okay, so that's how it works. Oh, the return true, since this is a timer function, returning true tells the system, keep the timer running. If I return false, the timer gets killed, and we won't come back here. The timer is turned on, I believe, in player.c. I've forgotten exactly where the timer is turned on. And it is set up as a parameter when you start the program up to tell it the resolution. If you don't tell anything, it's 100 milliseconds between calls. If you want it to go faster, you decrease that number. If you want it to go slower, you increase that number. So if you said 500 milliseconds, it would only do it twice a second, in which case the meters would move very sluggishly. If you go to 50, it's going to call, this function will be invoked 20 times a minute, or excuse me, a second, and the meters will be more jumpy. And you really don't get any extra. You're just increasing your overhead. 10 times a second seems pretty good. 120 milliseconds seems pretty good too. It's whatever you feel like doing. All right, so that's the basic audio that's going on. That's the basic handling of the audio signals. The actual audio is created by VLC and the VLC players and the VLC libraries. But that's how I actually fetch the audio out of Pulse. There's other audio systems in Linux, Jack Audio, for example. And Jack Audio is different. I don't handle Jack. Jack's more complicated. Jack's very good. but not a lot of people really are using it. It's got an awful lot of great features to it. I don't know if it's really all that much actively under development, but Jack also runs on Windows, although I've never tried it on Windows. I have tried it on Linux, but a lot of things are not compatible with it. A lot of the browsers are not compatible with Jack. Everything's compatible with Pulse, and everyone says, Pulse is awful. Well, it's not that awful. It actually does the job, and it's been there forever, and it's under active development. So that's a description, hopefully not too confused, of the internal audio.